Hey everybody, here is going to be our lesson for part 2, or I guess day 2, of our simplifying radicals notes and the last part of rationalizing our denominators. I'm going to do a review. So we've already done number 9. I'm just going to do it again with you. And then you can try the other 4 and then check how you did. And we'll do the same process for the next page as well. Before I do that, I'm going to write our perfect squares right here so we don't have to keep going back and forth. So 1 squared is 1. I'm not going to write that one down. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 36. 49. 64. 81. 100. 121. 144. 169. 196. And 225. So that gives us 1 through, really 2 through 15 squared. Remember, the first thing we're going to do is look at our square root and ask ourselves, is this a perfect square? If it is small enough to be within our list of perfect squares, we can just see if it is. See, there's not a 162. It would fall right in here. If it was bigger than our list, like number 11, we're literally just going to check and see if it is a perfect square on its own. The way you would do that is just type in the square root and then whatever number you're trying to find. Let's say you had 400, you would just type in 400, and I'll tell you. Ours right here, the 162, is not a perfect square. It is somewhere in here. So we're looking at the squares that are less than 162. But my goal is to simplify by dividing by another perfect square. So I want a perfect square times something. I'm going to go back to my calculator. I might not know this off the top of my head. And I'm going to look at what's half of 162. The reason I'm doing that is because it couldn't be any bigger. Sorry, there we go. Couldn't be any bigger than half of 162 because it has to be something times 2 is the biggest it could be, or something times 3, times 4, etc. So I want to see what half of 162 is. That is 81, and that actually happens to be a perfect square right there. So 81 times 2. And then the square root of 81 is 9. So instead of writing the square root of 81, I would just write 9 times the square root of 2. And that was our answer. Remember, you're always going to make sure that everything inside your root symbol is fully simplified, meaning it could not be divided by another perfect square. And there we go. So go ahead and pause, do 11 through 14, and then come on back when you're ready to check it. Here are your answers if you want to check them. 11 and 13 were perfect squares, meaning that an exact whole number times itself makes the radicand in here. Same for this one, 5 times 5 is 25. Remember, the ones where we don't have a perfect square, that means we didn't have any single number times itself to make our value. An easy example would be right here. We have 96. 10 times 10 is 100, and 9 times 9 is 81. So it'd be somewhere between 9 and 10, closer to 10. But since it's not an exact number, that's why we're simplifying. So for number 12, we could do 16 times 6, and the square root of 16 is 4. And then for number 14, it was 108. That is also not a perfect square, but it is 36 times 3, and the square root of 36 is 6. And there we go.